This is David Hamill, Director of the HL7 Project Management Office. Welcome and thank you for joining us. Today, our session will focus on CDS hooks and will be presented to you by Dennis Patterson. Dennis, are you ready to begin your presentation?
I am. Let me share my slides. All right, welcome to Remote Decision Support with CDS Hooks. My name is Dennis Patterson. I'm responsible for infrastructure of Cerner's open platform products, but I'm here today in my role as a committer on the CDS hook specification to walk you through the spec and give you a feel for how it works. So let's start with an inherent challenge that comes with smart apps. We'll take this example of a bilirubin chart app. So it's applicable for newborns who are less than 120 hours old when their bilirubin results are either not documented or outside of the accepted range. So a provider that's going to make use of this app for treating such a newborn first needs to know that this app is available in their system. So they need to know that the place where they are practicing medicine has this app available. They purchased it and they've configured it to be useful to them. Second, they need to know that the app is relevant to their current situation. So this might be fairly straightforward in the case of a bilirubin chart app. They might be able to keep track of these various criteria, but you could extrapolate this general problem across a whole host of different smart apps. And they would need to keep track of all of the criteria for which each app would be relevant to them. And thirdly, they have to be able to find the app and launch it. So it's not enough to know that it's available to them somewhere in the healthcare system, but they need to know what series of menus, where do they go to navigate to find this app in order to use it. So this was the initial use case behind CDS hooks. How could we kind of proactively recommend an app to a provider that would be beneficial to them? Simply put, CDS hooks is a vendor agnostic remote decision support specification. So it's vendor agnostic, meaning it's not specific to any one EHR system. And it's an API specification, obviously designed for decision support, but more specifically designed for interacting with a remote decision support service. So it originated from the team behind Smart. It's open source and it is an HL7 standard. So one of the questions that you might be asking yourself is, wait, doesn't FHIR already define an approach for CDS? And you'd be correct, that's true. There are clinical reasoning resources within FHIR. The good news here is that there's harmony between these two approaches. They're both governed by the CDS working group within HL7. And there's some overlap, but there also is a bit of a unique focus to each. So clinical reasoning resources are very much focused on local decision support. So what I mean by that is modeling within a FHIR server the specifics of decision support. So things like using CQL to model rules. Whereas CDS hooks is not so much focused on the how, it's more focused on how do you communicate with some service that lives somewhere, tell it about an event and receive back decision support. Now, that service may use clinical reasoning resources behind the scenes, but that's not a concern of the spec. So let's talk vocabulary a little bit here. That remote service I mentioned is a CDS service, and it's a service that's invoked by the CDS client via a hook. So CDS client, you can think of something like an EHR or a patient portal, some user interface that someone's interacting with in a healthcare situation. A hook is another name for an event or a trigger. That service, once it finds out about one of these hooks, one of these events, will evaluate its own logic. It has FHIR data at its disposal. So not only does it know about the event, but it can find out other information about that patient. And then once it's made some determination, it can return decision support via what the spec calls cards. And we'll dive into each of these. But when I say it implements its own logic, I really mean it. That CDS service could be very procedural in nature. It could be a series of if-else statements. It could be more sophisticated. Might be a machine learning or a neural network, or like I said, it could be using CQL behind the scenes. But it could really be a mechanical Turk or a Ouija board. The specification is not concerned with the logistics of what the CDS service does, as long as it adheres to this API contract for communicating its decision support. So some of the example hooks, there are a number of them. These are the three most mature hooks. So first we have patient view, and this correlates to when a patient's chart is opened. And the next two are different stages in an ordering workflow. So first you have when a clinician is selecting an order for placement. So you can envision they're treating a patient, they search for some orderable, and they select it. They may not have solidified all of the details for that order, but they've indicated the intention that they're planning to place it. When it's all finalized, then that order and any other orders that might be queued up would go through the sign workflow, and the order sign hook would be triggered. So let's look at this visually with an example workflow. So the provider's treating a patient. They select a particular medication here. That would trigger a CDS hook. Here we'll say order select because they've just selected it. And one or more CDS services, so here maybe three, are listening for that hook. So the CDS client, that front end, tells those CDS services about that event. Then they will execute their own rules. They can leverage FHIR data as needed to better understand other aspects of the patient's record, and ultimately return CDS cards, which are rendered and displayed by the client back to the user. Now, those cards can have a variety of different types of information in them. It could be very textual in nature. So here, a simple example is just price information. They could be more actionable, so actually giving a suggestion to the user rather than something that they only have to interpret and make a decision on. By providing a button, they can immediately just click that if they choose to accept that suggestion. And lastly, circling back to that original use case I mentioned, recognizing that there is a smart app available in that system that could be beneficial for them if they want a more rich workflow for treating that patient. So getting into the technical weeds a little bit, when the CDS client tells the CDS service about a particular event, they issue an HTTP post to that service's endpoint with a JSON payload that communicates, well, what is the hook? There's a unique ID for this instance of the event, information about how to get more information from the FHIR server, and then some contextual information about the event. And there's some other fields, but these are some of the core fields that might be typical of such a request. That CDS service will execute its logic and ultimately return back a 200 with an array of cards. Now those cards, there could be any number of them. So if the CDS service looks at this situation and determines that they don't have any guidance to return, they would return an array of no cards. If they have multiple cards to return to the user, they're free to do that as well. And then the CDS client renders each card as it sees fit. So rather than, as is common with smart apps, where the smart app developer is very concerned about the look and feel of their smart app and how it matches in that EHR, here you have the response being JSON, and the CDS client is responsible for rendering that information. Now there's some aspects in there, some attributes that can influence that rendering, but this also has the benefit of allowing the CDS client to render that guidance alongside its native decision support guidance and have it be as seamless as possible. At minimum, each card must have these three things: a concise summary, an indicator denoting the importance of the card, and information on the org or data set that's the source of the card's data. So in other words, what's the essence of the decision support? How important is it, and on what authority? Why should I, as a provider, be concerned with this recommendation, or how trustworthy is it? And here's again is a look at that card response with just those minimum elements. Obviously, based on the previous slide that showed different types of guidance that could be returned, there are other attributes that can come back in this response. So that card indicator that denotes the importance of the information. It could be an informational card, a warning card, or a critical card. And what this can tell the CDS client or give a hint as to how that card might be rendered. Each CDS client can make this determination for themselves, but a CDS client might use this to render a different color scheme on a particular card. Or perhaps if it's a critical card, it would render that as a modal pop-up and be very interruptive, ensure that the provider sees this information and deals with it because of its criticality, versus something that's more informational, might not be near as critical, could be displayed in a much more passive manner, not overwhelm the provider with alert fatigue, but something that's off to the side if they choose to look at it. So let's look at some more real world card examples that have come through HL7 Connectathons over the years. So here's an example of an information only card, just telling the provider about a conflict between a medication and a genotype. You could have that, again, something more actionable, a suggestion that because the medication has a conflict with the patient's race, they might want to consider switching to an alternate medication. So behind the scenes, this is actually communicated from the CDS service in FHIR format. So the CDS service returns the medication as a medication request. And then if that is accepted by the clinician, the CDS client would convert that into swapping out what's on the EHR scratch pad, for example. And thirdly, a link to a smart app that might be beneficial. Now, while these can be referred to as information-only cards, suggestion cards, or app link cards, these are really colloquial terms. There's no card type attribute. These are just the types of guidance that can be returned. And CDS services are free to mix and match these different types of guidance. So here's an example card that has a bit of each. You have information and a suggestion and link. Now, how does a CDS client discover what CDS services exist? So each CDS service provider has a base URL. And on that base URL, if you were to append /CDS services, you arrive at a discovery endpoint. This endpoint advertises all of the CDS services that are available at that URL. So it'll list them all out, as well as the hooks they're interested in and information about those services. So here's an example. If you were to issue a get to example.com/CDS services, you get back an array of services. And so for this service, it's interested in the patient view hook. There's a title and description for the service, the ID for the service, which is important to communicate to the client, understanding where it lives, how to call it. And then there's also a prefetch request of some data that it wants sent along with the notification of the event. And we'll get into prefetch a bit more later. So note the correlation here. On that discovery endpoint, they had that ID of example service. And so by appending that on to the end of the path here, that's the path that the CDS client would send the post to tell that service about the patient view event. So what kind of data access is available to a CDS service when it finds out about one of these events? Well, of course, they have their own proprietary data sources that might make that particular service unique or otherwise give it value in a clinical workflow. There is hook context data that is pushed to the service along with the notification of the event. So there's core information about that event. There can be prefetched FHIR data pushed to that service. So we saw that advertised and requested in the discovery endpoint. It can ask for other aspects of the patient's record that it wants sent along with notification of that event. And thirdly, there's the option for that service to be able to call back into a FHIR server to do its own queries for FHIR data. We'll go through a couple of these. The hook context data. So every single hook has its own page that'll define its own workflow and its own context. It defines data that's specific to that hook. So as you can imagine, a patient view hook and an order select hook aren't going to have the same exact context data. The order select hook is going to have a representation of the orders that were selected or being signed. And it's data that all CDS services using that hook would use. So with patient view, You might be tempted to say, well, the full patient resource should be sent along with that event, but not necessarily. Not all CDS services may need the full patient resource. So if you boil that down to what's core about that event, it would just be the patient's ID. And if a service needs the full patient resource, they can ask for that as part of the prefetch or query the FHIR server. And the hook context data can be FHIR data or references to FHIR data, but not always. In other words, there's no requirement in the spec that the hook context data is a FHIR resource or FHIR reference. So in this example for patient view, we have a user ID, which is not only the logical ID, but also the FHIR resource type. You can envision that in an EHR setting, this might be a practitioner opening the patient's chart, but the patient portal may have a patient view scenario as well. So we allow for multiple resource types to be used there. Patient ID is just the raw ID of the patient in the system, and then optionally an encounter if the patient's record was open in the context of an encounter. The prefetch data that's pushed along with information about the event. So this is always FHIR data, and it's data specific to a given CDS service. So in other words, if multiple CDS services are listening for the same event, each service does not get the total of all of the various prefetch requests. Each service would get only that prefetch data that it asked for. Also note that CDS clients are not required to honor prefetch requests from CDS services. And that just suffice to say that prefetch is one mechanism. And if a CDS service doesn't receive the data that it needs via prefetch for one reason or another, it should be ready to turn around and call into the FHIR server to retrieve that data. The prefetch requests are expressed as FHIR read and search queries. So here's a couple of examples. Retrieving the patient by ID. So just the full representation of that patient resource. Note here that there's a template ID that's used in this request. So context.patient.id means the hook context. You saw in patient view, there is a field called patient ID on the hook context. And that's what this is referring to. Use that ID in retrieving the patient. Another example would be getting the capability statement. Maybe a CDS service knows that it's going to have to call into the FHIR server to retrieve other resources. And so it wants the capability statement pushed to it so that it knows right off the bat what resources are available in that system if it wants to do that as a dynamic runtime decision. So why prefetch? Why might a CDS client or CDS service leverage prefetch? There's a few reasons. One, that the CDS service always needs some set of data. So you can imagine a CDS service may check some piece of data first, but then other pieces of data on the clinical record might be more secondary. They might only need them in certain situations. So it might be a procedural set of logic where there's multiple branches, and depending on what it finds on certain resources, it might look at others. So it might define those resources that it always needs as part of prefetch, and then decide that for those subsequent resources that are only need sometimes to query back into the FHIR server. There's an efficiency gain. So multiple CDS services might want the same set of resources about that patient. And so there's an opportunity for the CDS client to consolidate any duplicate prefetch requests into fewer requests. So rather than telling 3 services about some event and then all 3 services executing the same request back to the FHIR server, it's much more efficient, especially when a provider is actively treating a patient, for the client to push that out to them along with the event. And then closely related to that, just performance gain. So because the CDS client might be able to retrieve that data in a more performant manner by virtue of it being already in memory or in cache, or just being closer to the data, there might be less latency. And those are all good reasons why prefetch might be of benefit in the context of a decision support workflow. So to recap the basic flow, let's look at a separation of concerns. So the CDS client is responsible for understanding the workflow and the various hooks and triggers gathering that context data that's going to be pushed out to the services. And doing so, then the CDS service provider is responsible for its own decision support logic, ensuring that it gets any other additional data that it might need. And ultimately, the CDS client is responsible for ensuring that's presented back to the user in a helpful manner. So as you start getting comfortable or coming up to speed on the way these APIs work, I would point you to a cheat sheet. This is out on cdshooks.org. There's a diagram there that we've seen with the basic workflow, but it goes through some of the API structure for the discovery mechanism, the request and response for telling a CDS service about these events. It doesn't contain all aspects of the spec. Each field is just briefly summarized, so you could fit it in this as like a one-stop shop. But it's helpful as you're getting your feet wet or as you're developing an implementation to have something that's just a quick sheet there, at least with all of the 1.0 spec. We do need to update it for the stuff that's coming next, which I'll touch on a little bit later. So as CDS clients and CDS services interact with one another, we haven't yet talked about security. So how is all of this done in a secure manner? Well, there's three different aspects of that we'll touch on. So for one, how does a CDS client trust the CDS service? And it does so via its TLS protected endpoint. So you note earlier that once you have a particular base URL, all of the services exist underneath that base URL. So there's an established trust there between the CDS client and that URL. And the CDS client uses all of the standard certificate validation mechanisms that exist today on the web to ensure that that service owner is who they say they are. But then on the flip side, as a CDS service is offering their proprietary IP, they don't want necessarily just anyone going and trying out their algorithm. So they want to, or they may choose to limit who calls it for reasons of just protecting it or reasons for monetizing those CDS services. And so the CDS client sends a signed JOT or JSON Web Token along with its request to that service, which we'll look at in a minute here. And then the third aspect of security is the CDS client provides a fire access token to the CDS service. So among those three different ways that a CDS service can get data, one of them was calling back into the fire server. Well, it needs to be done in a protected manner. And so the CDS client sends that token, fire access token, that's scoped to that particular user and that service so that the service can go make requests on that user's behalf. And because this is a backend service, but we have a token that's scoped to a user, there's no mechanism here for any kind of authorization code flow, nor would it be appropriate to interrupt the provider to have them do any kind of login. So it is the responsibility of the client to generate a token on that service's behalf, representing the user and pushing that out so that if the CDS service does need to call the fire server, it can do so in an expedient manner and get the data that it needs. So as for the JOT token that's sent with each request that authenticates the CDS client to the CDS service, if you haven't seen a JOT token before, this is essentially what it looks like. There's three sections that have been color-coded here for you. The middle section is the payload, which you can see decoded below. The third section is a signature, so that the CDS service can validate the token and fully trust it. And then there's a header that contains information about where the public key exists that corresponds to the private key that was used to sign this particular token. And so in that payload, you have an issuer that's the URL of the CDS client. So a URL that represents what EHR this event took place in. There's an audience parameter that maps to the individual CDS service that's being invoked. There's optionally a tenant field. So it might not be enough for the CDS service to want to know which EHR did this take place in. They might want to know which individual implementation of this EHR. So, which customer, which client of this EHR did this event take place in? And then there's fields to set a boundary time for when this token is valid, as well as a unique ID, since the tokens are intended for one-time use. So if you want to start trying out these APIs, we do have a sandbox that allows testing of 2 of the hooks. So this is a web, it runs entirely in the browser. There's no backend server for sandbox.cdshooks.org. Up in the right-hand side, there's a little gear icon. In there, you can point this to a different Fire server or to a CDS service that's running on localhost, really anything that the browser can access. The 2 different tabs correspond to the patient view hook, as well as order select with medications. On the right-hand side is a collapsible CDS developer panel. So if you were to go to that dropdown and select your service that you've told this sandbox about, you can see the payload that's being sent to your service, as well as what the browser sees coming back from your service. And then on the left-hand side, you'll see a rendering of any cards that your service returned. So this has been a helpful tool over the years to be able to test out these more mature hooks, these very commonly used hooks, and get developers up and running. There's a number of different EHRs and CDS clients that have been involved in testing the specification over the years, as well as several of these have production implementations of CDS hooks today. So, and then in addition to the CDS clients that have been trying this out since the beginning, there's a whole host of CDS services. And these icons are by no means exhaustive, but hopefully this at least gives you a sense of the amount of attention that the specification has seen over the years since 2016 or so, to ensure that it accounts for a variety of use cases and clinical scenarios. The Argonaut project has also shown a lot of love for CDS hooks here in the US. So back in 2017, they were focused on that use case of recommending a smart app given, recognizing a particular scenario when the patient's chart is opened. And then that year also funded a security assessment and threat model using the same company used to assess and threat model SMART. And then a couple of years ago, Argonaut was focused on the use case of pushing appropriate radiology ordering via a CDS service. So these are the PAMA workflows, Protecting Access to Medicare Act, noting that when an imaging order is being placed for a particular condition, giving it a rating whether or not it's deemed appropriate and will be reimbursed by Medicare. We released our 1.0 specification in April 2019, so we're a couple of years old now in terms of being a formally published spec. In the meantime, we've been validating and maturing hooks. So patient view, we've already worked through all of its ballot comments, and if it hasn't been published yet on the HL7 site, it will be any day now, which is exciting. And we'll quickly follow that up with validating the ordering hooks, since those are the next most mature. They're the next candidates. And then we validated a 1.1 specification. So there's some other features that have received some attention, some maturity, and we think that they're ready for that 1.1. And we're continuing to work through those comments. So what is in that 1.1 ballot? A few different things I'll touch on. One is system-only actions. So these are actions that are clinically safe to be conveyed by the CDS service and automatically applied by a CDS client without interrupting the provider. So this is typically more of a niche set of scenarios. In the PAMA example I highlighted, where the CDS service is conveying a rating. A rating is something that could be applied more behind the scenes without necessarily interrupting the provider unless there's a problem. So if they placed an imaging order for a condition that is going to be reimbursed by Medicare, it's deemed appropriate by the CDS service, that may be rendered by the CDS client simply as a green check mark, and there's no need to present a full-blown card to the provider to let them know they're doing a good job. Enhanced suggestion handling. So a couple different things we did in this space. One is that in the 1.0 spec on cards, when there are suggestions, it's a bit more of a radio button style choice. They're mutually exclusive, you need to choose one. And so what we did here is allow for you to have a little bit more of a checkbox style interaction. So break apart the suggestion to be a bit more modular and allow them to pick and choose which parts, as well as the ability to indicate that one or more aspects are recommended. So pre-check one of the suggestions, if that's appropriate. And then thirdly, capturing decisions. So we'll dive into this one a little bit more to explain what that means. So one aspect of the decisions is that a provider doesn't always accept a bit of guidance. They may override a card, they may dismiss it for a particular reason. And the CDS service is now able to return some of those reasons in a codified manner to let them basically to present some reasons why a particular piece of guidance is sometimes more common to, let me rephrase that. There may be common reasons why certain bits of guidance may not be accepted. And this allows the CDS service to return those to the front end in a codified manner. But it also pairs nicely with the next piece, which is, you'll notice this from the earlier slide, but with an additional arrow that's very helpful, which is that arrow number 4, and that once the user has interacted with the card, providing a feedback loop back to the CDS service. So especially if the user then shows one of those override reasons, that can be communicated back to the CDS service to inform it how its decision support is being used, and so it can make improvements or otherwise have useful analytics. Because before with the 1.0 spec, it didn't get that kind of feedback. And so now by making a post to an individual service's feedback endpoint, the CDS service can be informed about what suggestions were accepted or was the card overridden and why. And this in particular, both of those features, the feedback endpoint and the override reasons have been or have received the most amount of attention in recent connectathons. And there's a lot more excitement on those for being brought into the spec. Well, that's it for the majority of the content. I'll leave you with some links here to the latest and greatest specification and documentation, a link to the public sandbox. Also note that, again, that all of the specification is out on GitHub. So you can contribute back, you can get involved in the community, have discussions on issues about things you would like to see within CDS hooks or things you would like to see tweaked. Also, if you are technically inclined and you want to go and try some of this out as a CDS service, there's a tutorial available at this URL. If you were to go to this URL, it allows you to check out and run a couple CDS services directly on your machine or wherever you choose to deploy it, listening for the patient view and order select hooks. It walks you through how to connect those services up with the public sandbox so that you can invoke them from the front end. And then gives you some suggestions, if you will, for how to take those services to the next level. So if you were to enhance them, what are some of those things you could do just as exercises to help you learn the spec further? All of these slides are open source. They're available out on my GitHub. So feel free, I know the conference will make them available as well, but you can also download them here. I have made a couple tweaks since this particular version out there, but I'll have these uploaded by the end of the day. That's it. Thank you for giving me your attention and for hearing a bit about CDS hooks. Let me go to the Q&A and see if there are any questions. And if you do have a question and you haven't yet submitted it, by all means, put that out in the Q&A and I would be glad to read through those and answer what I can. I don't see any right now.
Dennis, we do have a few questions.
Okay. All right. Yeah, well, I'm not seeing them in my app. So yeah, if you would just be so kind as to read some of those to me.
Okay. The first question is, where can a list of implemented hook triggers for an EHR system be found, and how can new triggers be requested? There was a reply to that question. The reply was hl7.org CDS-hooks.
Yeah, so there's two aspects to the question.
Mm-hmm.
I'll take the second part first, because I think that's what the that reply was regarding. Yeah, so one thing I neglected to touch on is that the specification defines how hooks can be defined, but it of itself, like the core CDS hook specification, does not itself define hooks. And so what that allows for is a bit of a decoupling so that the core framework can be present, but the number of different scenarios and triggers can continue to evolve and grow independently. And so, yes, if you have a particular workflow that you see as a candidate to be a hook, the GitHub website, for sure. Well, actually, if you go to the spec, I believe there's a page, I don't have it right offhand, but I can certainly send that out, defines kind of a process for how you do this. Ultimately, you would want to start a communication out on Zulip. You want to kind of get a feel for whether this is a legitimate use case. Do EHRs support this kind of trigger in their systems? You would log a pull request if you have just enough sense, enough confidence in this particular hook that you want to go ahead and give it a stab at defining the workflow and put that up for review. That pairs nicely with the Zulip discussion because then people can see exactly what you're talking about and give you feedback. But the first part of the question is, where do you go to find out, how for the different EHRs, what kind of hooks they support? And I think the best way is to go to those EHRs, go to the people that in the community, perhaps of those EHRs, or if you aren't sure who to ask, you could always go out on chat.fire.org to the CDS hooks channel and say, hey, who is a good representative from such and such EHR that I could chat with a bit about CDS hooks to find out where the support is at. But each of those EHRs would be able to better explain the level of support and what's in the works and so forth.
Okay, thank you. The next question is, does encounter status, planned, in progress, etc., play any role in how often a hook may be called? For instance, the patient view hook.
Yeah, that's a great question. So there's two aspects to that. And I think part of the question comes from the perspective of, okay, if I'm a CDS service and I'm listening for patient view, am I going to get called for literally every patient that gets open in that particular system? Because that's usually not what the CDS service is interested in. There's usually particular scenarios. And so there's a twofold angle on how to tackle that problem. And one of the mechanisms that exists today is that the EHRs that are implementing this already have rule systems today where when they're configuring when a CDS service should be called, they're able to set up and customize that a bit. So, if your CDS service should only be called in certain scenarios, there's some of that can be done kind of outside of the specification, kind of out of band in that configuration where you would communicate to the CDS client, make sure that this is only configured so that I'm called in these particular scenarios. However, you also recognize that it would make sense to have this captured somewhere that's a bit more interoperable. And so I think there's a GitHub issue around this. I know I've been part of conversations on this, but we've tossed around the idea of what we call trigger guards, which might manifest itself in a way like in your discovery endpoint to be able to provide some information like that. It's not yet determined whether that would be kind of free text explanation as to when the service should be called. Ultimately, it would be nice if it was a bit more programmatic, but understand that the rules there could get pretty complex in trying to represent all of the different scenarios when the service should be called. So ultimately, there's a bit of responsibility on both ends. You want to ensure that whether it's advertised programmatically or not, the CDS client is not necessarily calling a service for every single patient or every single orderable. But at the same time, you use a CDS service, in part of your logic is going to be looking at that hook context and seeing, is this a scenario that I have interest in or that I am going to be able to provide any guidance on at all, and determining whether or not to proceed or return an empty array of cards.
The next question, is there a CDS service catalog? You showed the slide with vendors, but I am interested in a list of what CDS services they provide.
So, and I might have to ask for a little clarification on this. So I'm not sure if the question is asking at individual CDS clients or EHRs, what services have already been enabled? Or is the question, what CDS services exist in the wild? I can take I'll take a stab at the last one. And I think the question is, again, going to be reaching out on Zulip. I don't think there's any kind of direct catalog that I'm involved in where CDS services are advertising that that they want to be a part of some catalog. As for if you work for a healthcare institution that is involved with a particular EHR, then yeah, you would want to reach out to that individual EHR to say, hey, what services have been approved and onboarded, so that I can ensure that those services are at least an option to be enabled in my clinical system and set up those rules accordingly. So hopefully I answered both questions.
Do you want me to unmute Michael Vandersel, who asked the question?
Oh, sure. Go ahead. Hey, Michael.
All right. Michael, there you go.
Thanks, David. And thanks. Yeah, so this was basically my question. So just like you have an app gallery, I was wondering if there were a CDS service gallery somehow so that you can discover, because I know that there are certain services available, but I have no idea how to get there, or if there's options, or so you kind of answered my question.
Yeah. So I think, I mean, several of the HRs would have like smart app galleries today. I think the same kind of thing is true for CDS services. You just have to work with the different EHRs. But I mean, as for what services, I mean, obviously I already said that I don't have a catalog of all the CDS services that exist. But if you were to reach out on Zulip or just take a look at some of the more recent Connectathon write-outs, you'll see a lot of the same companies that have been coming that are actively working on CDS services. Probably if you look at the slide deck later and you go back to that NASCAR slide that has all of the different icons, you'd probably be able to get a host of names that you could reach out to as well.
Okay. Well, thank you, Dennis.
Sure.
I think there's one or two more questions, right?
Two more questions.
Okay.
First one is, what triggers Prefetch?
Okay, yeah. So again, a Prefetch is data that rather than querying into the Fire server yourself, you as a CDS service are advertising, you want this sent to you when a hook event occurs. So, if you have different services that are listening to patient view with different focuses, or even different services that are listening for different hooks, patient view versus order select, order sign, those are all going to be looking for slightly different variations, or maybe not so slightly different variations on different kinds of data. And for some of those optimization reasons I mentioned, if you know that this is something that you always need, that's definitely a reason to advertise that, if possible, in your discovery endpoint, and say, when you call my service, when you tell me that a patient's chart is opened, or when you tell me that a provider is in an ordering workflow and I'm called, I'm also going to need to know the patient's conditions, or I'm also going to need to always know, if they have a particular set of allergies. So please, CDS client, when you call me, if at all possible, send that to me. So what triggers the Prefetch is just the event itself, the opening of the chart, the ordering workflow. And then if that CDS client supports Prefetch for what you have requested, then it would do its best to ensure that that is sent to you.
Last question. Does showing CDS hooks work in mobile provider app? I mean, from the UI front with respect to showing the cards in this compact view. Any good reference of some implemented sample?
Well, that's a good question. So I think maybe to restate is, are there any mobile CDS clients? So you have a mobile version of some EHR, how exactly does this play out? That's a great question. Obviously with the spec being focused on JSON payloads, it does not dictate that form factor. But at the same time, if you had a mobile EHR and you're doing something and you tell a CDS service, and that CDS service returns giant cards, and there can certainly be UI challenges to ensure that that's presented in a useful manner. I don't have any good examples to point to you, but it's something that's coming. I've been doing the track leadership for the Connectathon track on CDS hooks for a number of different times now, and we haven't had anybody show up with their mobile CDS client that I'm aware of. But yeah, I do think that given that kind of form factor, there probably need to be some collaboration, a lot of UX input to ensure that it's something that's readable and useful to the person that's using that device, as well as probably a bit of collaboration with the CDS service to, you know, if there was some kind of problem in terms of, hey, maybe we need to break down the service into smaller components, or I don't know, I'm just spitballing a little bit here, but I would imagine there would be some collaboration as well as a whole lot of UX input.
All right, thank you, Dennis. We've kind of run a little bit over, and for those still here, definitely rate the session. Go into Whova for this session, and there's the rate the session button. If anyone else does have questions, you can put them in the Q&A chat, and then we'll ask Dennis if you could hop into Whova every now and then and check the Q&A portion there and answer them accordingly, because the Q&A in Whova does stick around even after the entire week's over. Okay.
Yeah, and you can also use that Zulip stream for CDS hooks, or I'm on Zulip, chat.fire.org, if you have further follow-up. Thanks, everybody.
I always forget about Zulip. Great suggestion. Bye, everyone.
See ya.